Hi everyone, good evening. So we are in the sixth session of electric potential and capacitor topic. In Kerala, we will talk about two things. One, the concept of potential energy of a dipole in uniform electric field. So uniform electric field kulla nama dipole place panna, what will be the potential energy associated with the dipole? Okay. அதுக்கப்புறம் we'll also touch upon already நம்ம இதை பத்தி பேசியிருக்கோம், but we'll also touch upon the behavior of the conductors. ஏன்னா இதுக்கப்புறம் we'll go and discuss about the dielectrics. Already conductor behavior பத்தி அப்பப்போ we talked about some of the properties, right? But இங்க என்ன we'll try to summarize all the properties of the behavior of the conductor. ஏன்னா இது முடிச்சிட்டு we'll go to the dielectrics. Okay, so it will be a continuity part of it. Okay, so first we'll start with the potential energy of a dipole when we are keeping the dipole in a uniform electric field. Okay, so uniform electric field kulla நம்ம dipole place panna, we will try to find out what will be the potential energy that is associated with the dipole. Okay va, adukku enna we will start with the dipole which is kept in a uniform electric field. inga parunga, let's say there is a uniform electric field ipdi towards the right side, அதோட value E ன்னு வெச்சுக்கோங்க. Okay, now we are having a dipole. பாருங்க, dipole is kept like this. Now the electric field will create a torque on the dipole. What will be the torque value? The torque will be equal to what? PE sin theta dana. And inga parunga, what will be the torque or a turning effect? P cross E. So vector notation lepdi, how do you give the torque acting on the dipole? P cross E, right? So inga parunga, P is like this. We have to curl our fingers to reach E. Apadi curl panna, then what you have? The turning effect of the torque. Inga eppadi varudhu parunga, the turning effect of the torque is in which way? It is in the clockwise direction, which means the dipole, right, அது அப்படியே இருக்காது, it will keep rotating because of the torque that is created by the uniform electric field. அதனால it will keep rotating. But இங்க என்னன்னா, if we want to stop the dipole from rotating automatically, so ஏன்னா இப்போ if the dipole is rotating automatically, அங்க என்ன ஆகும் தெரியுமா? The dipole will start getting the rotational kinetic energy, because if an object is rotating on its own, right, it is under the influence of a net torque. அதனால என்ன ஆகும்? The dipole will start gaining rotational kinetic energy. So அப்படி இல்லாம, if say for example we are applying an external torque, so if you don't allow the dipole to rotate automatically, we are applying one external torque in a opposite orientation. We are applying an external torque in an opposite orientation to the torque because of the electric field. Already because of the electric field, dipole ku mela there is a torque. Adanal the dipole will always have a tendency to rotate. But inga நம்ம என்ன பண்ணிட்டு இருக்கோம்? We are applying an external torque. Opposing orientation, we are applying external torque. Okay, if this external torque value, right, is almost equal to the electric field torque, அப்போ almost the net torque acting on the dipole will be zero. If the applied external torque is almost equal to the electric field torque value another P is entrana, then this dipole will be almost at rest, equilibrium and solla, because both the torques are what opposing. If say for example we are giving a external torque some slightly higher value, konjam, like we can't even measure how much high it is, we are giving a very very small higher value. For the sake of calculation, நம்ம என்ன யூஸ் பண்ண போறோம்? We are going to use the external torque value as P sin theta only, but we will have the external torque value marginally higher, very very marginally higher value இருக்கும். Okay, அதனால என்ன தெரியுமா, இப்போ இந்த ஆன்டி clockwise directionல the net torque will exist, but the value will be very small. So as a result, the dipole will keep rotating in the direction. The dipole will keep rotating in the anti-clockwise, but it will rotate very slowly. So the dipole, while it is rotating, because of this applied external torque, it will rotate but very slowly. So adanala the torque, right, will not be able to generate any kinetic energy in the dipole. Kinetic energy generate agadu, but it will change the orientation. Ipo parunga, initially let's say inga irukra angle theta a nu vechukonga. Initial orientation of the dipole with respect to electric field evlo theta a, final orientation theta b. So slowly the dipole is rotated from theta a orientation up to theta b. Inga enna theriyuma, we will try to calculate what is the work done by the external torque. Now we apply a torque, we are applying a torque, right? That value is P sin theta. Exactly almost same as our torque due to the electric field, but we are applying the opposite orientation. So if we are giving a very small, the applied torque or the torque because of the field, they change depending upon the orientation between the electric field and the dipole. We will consider at a general point. Our general point, we will look at the small work done in rotating the dipole. So what is the small work done? The torque value into small angular displacement. Normally in case of the translation motion, right, work calculate work will be equal to what? Force into displacement. Torque into angular displacement. In case of the rotational motion, work formula is torque into angular displacement. So torque into angular displacement. So torque value P sin theta. So this is the small work done in rotating by an angle d theta. Now we are rotating the dipole from initial arrangement and the theta a angle, and we are rotating it till the angle between the dipole and the electric field is becoming theta b. So now we want to find the overall work done, means in the expression integrate pananu. We should integrate the expression. Angle from theta a, initial orientation is theta a. The dipole is making an angle theta a with the electric field. And the initial orientation and up to the final orientation theta b. Integrate pananu. Integrate panna, what is it going to give us? It is going to give us what is the total work done by the external torque. Apply torque, we are applying the torque, right? So what is the work done by the external torque? It is going to give us the work done by the external torque. This is the PE constant. PE integral theta a to theta b sin theta d theta. So integral sin theta d theta, it will be minus cos theta. Integral sin theta d theta minus cos theta. So P into minus cos theta, limits substitute pananu. Initial limit theta a, final limit theta b. So it will be what? P into minus cos theta b minus of minus cos theta a. Okay, so minus of minus plus. So what is the work formula? P into cos theta a minus cos theta b. What is the work done by the external torque? Apply an external torque. What is the work done by the external torque? Pe into cos theta a minus cos theta b. Okay, now this is what is the work done in rotating a dipole without gaining the kinetic energy. So if we rotate the dipole is not gaining any kinetic energy. Okay, so what is the work that we are doing in rotating the dipole? Then the P into cos theta a minus cos theta b. So for final formula, what is it? If you are rotating the dipole, the uniform electric field, we are placing a dipole. Okay, so we want to rotate the dipole without allowing it to gain initially theta அங்கலேருந்து we are slowly rotating it so that the dipole is not gaining any kinetic energy. This is the final position. The angle here is theta b. When you rotate it, the work done by the external torque means we are doing it. நம்ம அப்படி rotate பண்ணோம்னா we should do the work. அதோட வேல்யூ என்ன? Pe into cos theta a minus cos theta b. Here theta a is what? Initial orientation. Orientation and sonna what is it? Angle between the dipole moment and electric field. Theta b is what? Final orientation. Okay va? So this is what is the work done in rotating dipole in uniform electric field. Is important. Another, without gaining kinetic energy. So we are not allowing the dipole to gain the kinetic energy. Okay va? So this result, right, is what we are going to use for the potential energy concept. Now we'll talk about the potential energy of a dipole in uniform electric field. Talk about the potential energy of the dipole in uniform electric field. So இதுக்கு முன்னாடி நம்ம கிட்ட இருக்க result என்ன? If you are having a uniform electric field, அதுக்குள்ள we have a dipole. Okay, so dipole place பண்ணா, if you are rotating it from the initial orientation theta a and the final orientation, we are rotating it, right? Final orientation என்னது? இதனா theta b. அப்படி rotate பண்ணோம்னா the work done by the external torque, அதோட வேல்யூ என்னது? Pe into cos theta a minus cos theta b. இதுதானா? Now remember, here when the dipole is changing its orientation from the initial state to final state, இதுல kinetic energy change கிடையாது. Then what is happening to the work that we are doing? We are doing the work, right? அப்படி நம்ம rotate பண்ணும்போது we are doing the work. என்ன ஆயிட்டிருக்கு? What is happening to the work? The work must be stored as some form of energy, right? Already in the work energy theorem, அதுல என்ன? What is it that we study? The work done by the external forces, right, is equal to what? Change in kinetic energy plus change in potential energy. This is our energy theorem concept. Inga change in kinetic energy kadayadu. Why? Because we are moving it slowly. So kinetic energy varalenga. Which means what? We should have a potential energy associated depending upon the orientation or position of the dipole. அது எப்படி அதோட ரிலேஷன் எப்படி வரும்? The work done by this external force. Work done by the external force kadayadu, inga torque. So force and சொல்லல or torque. Because நம்ம normally translation motion என்ன வரும்? Work done by force வரும். Inga work done by torque because it is a rotation motion. Okay va? So work done by the external force or torque will be related to what? Potential energy. Eppadi? Change in potential energy. Okay, so change in potential energy and sonna what is it? It is the final potential energy minus initial potential energy. Adana final potential energy minus initial potential energy. Okay, inga paranga, what is this? The work done by the external torque எவ்வளோ? P into E, அதுக்கப்புறம் cos theta A minus cos theta B தானா? So this is what is change in potential energy, final potential energy minus initial potential energy. Okay, so இப்படி தான் நம்ம potential energy define பண்ண போறோம். So how the potential energy is defined? When we are looking at what is the work done by the external torque in rotating the dipole, right, where the dipole is not gaining any kinetic energy gain கிடையாது. So அதனால whatever the work that is done should go into the change in potential energy. So the dipole is going to get a potential energy value depending upon the orientation. அது எப்படி ரிலேட் ஆயிட்டு இருக்கா? How is it related? Because the work done by the external torque is equal to what? Change in potential energy. Okay, இதுல என்ன? Because whenever we look at any potential energy concept, right, always we'll have change in potential energy da varum. Anga absolute value of potential energy varadu. Even when we talk about gravitation potential energy concept la appadida, electrostatic potential energy concept la appadida na. Like when we talk about potential energy of two charges q1 and q2, adukku namakita formula enna? For a pair of charges, right, what is the potential energy formula? K Q1 Q2 by R. We have taken the reference. Reference is what? When the charges are infinitely separated, we have taken the potential energy of the value as 0. That is the reference, right? So whenever we want to have absolute value for the potential energy, and a potential energy and the definition usually we will get only the change in the potential energy. Absolute value of potential energy varadu. So namakku oru absolute potential energy venumanna we should consider what? The reference. Edavadhu oru arrangement or oru position nama reference edukanum. So inga enna theriyuma? The theta is equal to 90 degrees. Means what? Dipole is making an angle of 90 with the electric field. And our orientation la we will consider the potential energy to be 0. Is the reference. So in the dipole in a uniform electric field, what is the reference we take? When the dipole is making an angle of 90 with the electric field, and our arrangement rate or on the configuration, the corresponding potential energy, this is the reference. This is a reference. Like normally in gravitational potential energy, right? On the surface of the earth, we'll take it as 0. If you go to height h means, we'll get the potential energy value as what? mgh dana. So on the mother we will take the reference as what? Theta is equal to 90. We'll take the reference as what? Theta is equal to 90. Okay, va? So here what we'll do is this is the formula we have, right? PE into cos theta A minus cos theta B is equal to potential energy final. Potential energy final means what? Potential energy in the theta B position. Okay, va? Minus potential energy initial means what? In the theta A position. In the formula we modify panna porom by using that reference. So consider the theta A is equal to 90. Theta A nama 90 adugu porom. Theta B will be general angle theta. Theta A evla 90. Theta B evla theta. Inga parunga. P into E. Idhula P ananadi dipole moment. E means electric field. Okay va? Cos theta A. Theta A evla 90 means cos 90 evla 0 dana. Minus theta B evla theta. General angle. So 0 minus cos theta is equal to what? Potential energy theta B. Okay, this is the potential energy in the general state. Potential energy in the theta A, that is our reference. Other than reference, it is going to become 0 now. So what is the value? 0 minus cos theta means minus cos theta. So minus P into E into cos theta is the potential energy of the dipole when the dipole is making an angle of theta with the uniform electric field. When we take the reference, what is the reference? The theta is equal to 90 position we are taking as a reference. Okay, va? So on the particular orientation la, the potential energy of the dipole is taken as a reference. What is it that we are getting? Potential energy formula. What is the potential energy formula? Potential energy of the dipole in a particular arrangement, theta is what? Minus PE cos theta. We can also write it like this. The potential energy PE cos theta means what? P dot E dot product. Because if you are having a dipole moment vector and electric field vector, what is P dot E? PE cos theta means we can also write it like what? Minus P dot E. So potential energy of the dipole either minus PE cos theta illana minus P dot E. Okay, va? So idhilenda conclusion this potential energy formula is always by using the reference. The reference the dipole making an angle of 90 with the electric field is the reference. Okay, va? Now the reference justify pandrathu. How we can justify the potential energy of the dipole to be 0 in that 90 arrangement. Uniform electric field dana. Uniform electric field you must have identical charge arrangement. For left side la, we should be having an identical positive charge. Electric field it will be from positive charge to negative charge. Right side la, we should have identical negative charge. அப்பதானே நமக்கு அந்த யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்ட் வரும். இங்க பாருங்க, if you keep your dipole at 90-degree position with respect to electric field, the electric field எப்படி இருக்கா, towards the right side. 90-degree position சொன்னா what is it? It is like your plus q இங்க வரும். so இதர் 90-degree position பாருங்க. so இப்போ இந்த 90-degree position என்ன தெரியுமா, the positive charge of the dipole. இங்க பாருங்க, dipole சொன்னா what is it? It is a combination of plus q and minus q. அவ்வளவுதானா? dipole சொன்னா what is it? It's a combination of plus q and minus q. இங்க பாருங்க, the positive charge of the dipole will be symmetrically இந்த பக்கம் it is symmetrically distance to positive charge. அந்த மாதிரி அந்த பக்கம் என்னது, symmetrical distance to negative charge. so remember, if you have same distance from that positive charge and negative charge, இப்போ இந்த சார்ஜோட பொட்டன்ஷியல் எனர்ஜி என்ன ஆகும், ஜீரோ தானா? if you keep a charge equal distance from a positive charge, அந்த பக்கம் equal distance from a negative charge, so what will be the potential energy of the positive part? It will going to become zero. அந்த மாதிரி இங்க பாருங்க, the minus q is also equidistant. the external electric field is created by symmetric charges தானா? so the dipole, when we keep it in 90-degree position, so when the dipole is kept in 90-degree position, அப்படி நம்ம place பண்ணா the plus q and minus q of the dipole at a positive part and negative part, right, will be equidistant from the symmetric charges of the field. angle is equidistant from the symmetric charges of the field. இப்போ uniform electric field சொன்னா it should be having what, symmetrical positive charge in the பக்கம், negative charge in the பக்கம். so the dipole at a positive part will be equidistant from both the negative charge and positive charge of the electric field. அதே மாதிரி the negative charge of the dipole minus q also will be equidistant. அதனால என்ன ஆகும், the overall potential energy of both the charges will be becoming what, zero. so this is the justification. so for theta is equal to 90 orientation, we are taking the potential energy value எவ்வளவு, zero, right? அதுக்கு justification எப்படி நம்ம கொடுக்கிறது, because நம்ம அந்த theta is equal to 90 orientation ல பார்த்தா the minus q and plus q of the dipole will be equidistant. இந்த பக்கம் equidistant, அந்த பக்கம் equidistant from the symmetric charges of that uniform electric field. அதனால the potential energy will be what, zero. okay, so this is the justification based on this reference. in the reference base பண்ணி what is the potential energy formula, minus p cos theta or minus p dot e. okay வா? now எப்போ maximum ஆயிடும், எப்போ minimum? what is the potential energy formula? potential energy formula என்னது, minus p cos theta. இப்போ பாருங்க, when theta is equal to 0, theta is equal to 0 means cos theta is equal to 1. அப்ப என்ன தெரியுமா, the potential energy will be minimum. so அதோட வேல்யூ என்ன வரும், இந்த thetaக்கு பதில் cos theta பதில் நம்ம 1 substitute பண்ணோம், அவ்வளவுதான். what is it, minus p into e. so minimum potential energy எப்போ தெரியுமா, what is theta is equal to 0 means parallel arrangement. remember, already theta is equal to 0 on the orientation பத்தி நம்ம பேசியிருக்கோம் when we talked about the dipole in the uniform electric field in that torque calculation. அங்க என்ன தெரியும், this arrangement, right, is also called as what, என்னது, stable equilibrium. இப்போ நமக்கு புரியும் why this stable equilibrium concept is coming. ஏன்னா because the dipole ஓட potential energy will be minimum in which arrangement, in the parallel arrangement. இங்க பாருங்க, theta is equal to 180 means what, இங்க cos theta ஓட value will be minus 1. then potential energy என்ன தெரியுமா, maximum. அது எப்படி வரும், cos theta பதிலா minus 1 substitute பண்ணா minus into minus becomes plus. so இது என்ன தெரியுமா, this is what we call as the anti parallel arrangement. என்னது, anti-parallel arrangement. So this is what we also call as unstable equilibrium. Is it unstable? Because the potential energy of that dipole is maximum in this. Both are equilibrium. Why they are equilibrium? Because the torque acting on the dipole will be zero in both parallel arrangement as well as anti-parallel arrangement. But parallel arrangement பார்த்தா the potential energy is what minimum. இது எப்படி தெரியுமா? I think நான் இந்த diagram உங்களுக்கு காமிச்சேன் நினைக்கிறேன். So இப்படி இருந்தா வெச்சுக்கோங்க. இதுல நீங்க ஒரு ஆப்ஜெக்ட் பிளேஸ் பண்ணா you try to disturb it. கொஞ்சம் நம்ம டிஸ்டர்பன்ஸ் கொடுத்தா what is going to happen? திருப்பி அது கீழே வரும். எதனால? Because the potential energy here is what minimum. இங்க என்னது? The potential energy is minimum. அதனால it will keep coming to that equilibrium. அதுக்கு நம்ம என்ன சொல்லுவோம்? Stable equilibrium. இங்க parallel position மாதிரி. அப்படி இல்லாம if you are having a setup like this, இப்படி தான் வெச்சுக்கோங்க. இன்வெர்டட் பவுலுக்கு மேல ஒரு ஆப்ஜெக்ட் பிளேஸ் பண்ணா அங்கல இருந்து நம்ம கொஞ்சம் டிஸ்டர்பன்ஸ் கொடுத்தா what is going to observe? அப்படியே அந்த ஆப்ஜெக்ட் கீழே வந்துட்டே இருக்கும். திருப்பி அந்த மேல போகாது. it will keep coming down. இதனால why? Because the potential energy here is what? Maximum. ஓகேவா? So parallel position potential energy is minimum. What is it? Minus P into E. So that is what we are calling as a stable equilibrium. So அங்கல இருந்து நம்ம dipole displace பண்ணா it will always have a tendency to go back. இதனால because that arrangement is giving us minimum potential energy. அப்படி இல்லாம if you are having a dipole in anti-parallel arrangement, அங்க என்னது? அங்கல இருந்து if you just disturb the dipole, right, அப்படியே it will keep rotating away from the unstable equilibrium. Because unstable equilibrium is what? Maximum potential energy. அதனால it will keep going away. அங்கல இருந்து நம்ம கொஞ்சம் displace பண்ணா it will keep going away. ஓகேவா? So this is about the maximum minimum potential energies. Maximum எப்போ reach ஆகும்? Unstable equilibrium anti-parallel. Minimum stable equilibrium parallel. ஓகேவா? So இது ஒரு important consideration. So இது base பண்ணி we will usually get questions also. Work done in rotating the dipole. So what is the work done rotating the dipole relation to potential energy? இங்க பாருங்க, if you are rotating a dipole from one orientation to other orientation வெச்சுக்கோங்க. So initial theta I, final theta F. நம்ம rotate பண்ணா, remember what is the work done by external force or external torque? It should be equal to change in kinetic energy plus change in potential energy. அவ்வளவுதானா? Work energy theorem. Work done by any external torque or force is equal to what? Change in kinetic energy plus change in potential energy. Maximum என்ன தெரியுமா? நம்ம கொடுத்த ப்ராப்ளம்ஸ்ல we will have kinetic energy not attained. Means என்ன தெரியுமா? They will assume that we are slowly rotating it. So அதுல kinetic energy term involve ஆகாது. Involve ஆகலன்னா what will take? Kinetic energy ஓட change we will take it as 0. But if they are mentioning kinetic energy means we will have to consider that also. இங்க என்ன தெரியுமா? Kinetic energy means what? Rotational kinetic energy வரும். What is the rotational kinetic energy formula? என்னது? What is the rotational kinetic energy formula? Half into I into omega square தானா? So I is what? Moment of inertia. Omega is the angular velocity. Okay. But அந்த kinetic energy term வரலன்னா then work done in rotating the dipole will be equal to what? Simply change in potential energy. Change in potential energy means what? Potential energy final minus potential energy initial. அவ்வளவுதான். Change in kinetic energy term இல்லன்னா. What is the potential energy formula? If you are taking at a particular orientation, இப்ப பாருங்க, potential energy final will be what? It will be minus P into E cos theta F. Potential energy initial எவ்வளவு? minus P into E cos theta initial. அப்படிதான் அந்த வேல்யூஸ் நம்ம அப்படியே எடுத்துட்டு சப்ஸ்டிட்யூட் பண்ணணும். ஓகே. So what is the work done in rotating the dipole? Change in kinetic energy term வரலன்னா வெறும் change in potential energy மட்டும். This is coming straight from that work energy theorem. எங்கல இருந்து வருது? It is coming from the work energy theorem. What is it? The work done by the external torque or whatever it is that is rotating the dipole is equal to what? Change in kinetic energy plus change in potential energy. Change in kinetic energy term வரலன்னா it will be simply equal to what? Change in potential energy. Change in potential energy means what? Final potential energy ஓட value minus initial potential energy. அவ்வளவுதான். potential energy formula enna, if the angle is theta, potential energy value evla minus pe cos theta. Idu mattum namakku ஞாபகம் இருக்கணும். Okay va? So this is how we will calculate the work done in rotating the dipole. Maximum cases la enna, they will not talk about the kinetic energy. Kinetic energy பத்தி பேசலன்னா what is it referring to? It is referring to the assumption that the kinetic energy term is not involved. Okay va? Means we will neglect the change in kinetic energy. And the term mattum we will just remove it. Okay. So this is the approach. Paranga, these are some of the questions that have come in the previous years. An electric dipole has magnitude of its charge as q. Charge evla q. And its dipole moment is p. Okay va? It is placed in a uniform electric field E. Enga nama place pannirkom? We have placed inside the uniform electric field E. Okay. If its dipole moment is along the direction of the electric field, eppadi iruka? Direction of the electric field. Direction of the electric field sonna what is it? Parallel position dana. Eppadi nama inda place pannirkom? We are keeping the dipole in the parallel position. Okay. Parallel position iruka. The force acting on it and its potential energy respectively. So already nama idhukku munadi force and torque patti discuss pannirkom already. What is it? If you have electric dipole, uniform electric field kulla nama place panna, whatever is the orientation, paranga, whatever is the orientation, the force acting on dipole evlo is zero. Adu it should not be just parallel. The parallel agala, or it can be theta is equal to 30, theta is equal to 40, theta is equal to 50. It can be any angle. Always the net force acting on the dipole placed in a uniform electric field another is zero. Erna, because the field is uniform, right? Whatever the force acting on the positive charge of the dipole, the force acting on the negative charge of the dipole அப்படியே cancel ஆயிடும். அதனால we'll have what? பாருங்க, the positive charge of the dipole will experience a force q into e. Negative charge will experience how much force? Minus q into e தானா? So அந்த ரெண்டு force அப்படியே cancel ஆயிடும். So irrespective of the orientation, orientation சம்பந்தம் கிடையாது. Irrespective of the orientation, the force acting on the dipole in a uniform electric field. That is important. Non-uniform electric field kolla pona, it will be different situation. But in another uniform electric field, inside the uniform electric field, always the force is zero. In the idhilende we will be able to mark what is the correct option. Paranga, where is enga irukka? Only in option C they are saying force is zero. Option C la mattum they are saying force is zero. Mathadhila enna? Option A la they are giving a value for force, so idu kadiyadu. Option B liyum they are giving a value, adu kadiyadu. Option D kadiyadu. So like this we will be able to answer the question even if we know just one of the statements. Okay. Apdi nama conclude panna, we will be able to save the time. Nama apdi conclude panni we can go to the next question. Adilundu we will be able to save some time. So paranga, we don't need to look at the potential energy. But namak already theriyum what is it? It's potential energy. Parallel position la what is the conclusion we have drawn just now? In parallel position, another potential energy minimum dana. In parallel position potential energy eppadi irukum? Minimum. So that is what we call as the stable equilibrium. Okay. So option C is the right answer. Check pannunga. Okay. See, நான் திருப்பி சொல்றேன், like whenever we are having these kind of questions, right, ஒரு சில questions இல்லைன்னா they will be asking us 2-3 values. அந்த மாதிரி இல்லைன்னு தெரியுமா, because it is always about the time for us. Time is the most precious thing, right? நம்ம எக்ஸாம்குள்ளே போனால் time is the most precious thing. And lot of students அவங்க என்ன சொல்லுவாங்கன்னா, like physicsல we are not able to solve the questions in the given time. How do we overcome that? Like in questions like this, right? This is a question that has come in the previous year NEET. இந்த மாதிரி questionல you see one of the things. So first and the force மட்டும் நம்ம analyze பண்ணா, what is it? We are saying only one of the options is giving us the correct answer. So அப்படி tick பண்ணிட்டு we should go to the next question. அப்படி பண்ணதா we will be able to, என்ன சொல்றது, we will be able to comfortably solve all the question within the given time. Even match the following மாதிரி questions இருக்கும், அதுலயும் அப்படிதான். If you are having like say like by looking at one or two quantities, right, அதுலேருந்தே we will be able to sometimes conclude the answer. ஸோ எங்கெங்கே நமக்கு அந்த மாதிரி ஒரு ஆப்பர்ச்சுனிட்டி இருக்கோ அதை நம்ம யூட்டிலைஸ் பண்ணணும். ஸோ அப்போ தான் we will be able to save the time and we can comfortably solve all the questions. இல்லைன்னா we will be stuck with that usual problem that இப்போ NEET 2020 மட்டும் people have not given the complaint. ஏன்னா நிறைய questions என்ன தெரியுமா, வெறும் அந்த ஸ்ட்ரெயிட் ஃபார்முலா மாதிரி வருது. பட் in the previous NEET question papersல like one of the usual complaint என்னன்னா physics will be lengthy and solid. That is a usual concern. அதை நம்ம எப்படி ஓவர் கம் பண்ணுறது, we will have to make sure that எங்கெங்கே இந்த மாதிரி ஒரு ஆப்பர்ச்சுனிட்டி இருக்கோ we should try and make use of it. ஓகேவா? ஸோ பாருங்க அடுத்த கொஸ்டின், இதையும் ப்ரீவியஸ் இயர் கொஸ்டின் தான், 2006ல் வந்தது. an electric dipole of moment p is lying along the uniform electric field. lying along the uniform electric field ன்னு சொன்னா what is it? இது என்னது? parallel arrangement. இனிஷியல் எப்படி இருக்கா? parallel arrangement. ஓகேவா? இப்படி இருக்கா? parallel means theta is equal to 0. ஓகேவா? the work done in rotating the dipole by 90. இப்போ இங்கலேருந்து we have to rotate it by how much? 90 degrees rotate பண்ணா it will become like this, right? so theta final எவ்வளோ? 90. what is the work done? so இங்க என்ன பாருங்க, kinetic energy பத்தி அவங்க மென்ஷன் பண்ணல, which means we will use this relation, right? work to be done is equal to what? வெறும் change in potential energy, which is what? potential energy final minus potential energy initial. so potential energy final எவ்வளோ பாருங்க, minus p into e into cos 90. cos 90 எவ்வளோ? 0, which means final potential energy என்னது? 0. potential energy initial எவ்வளோ? minus p into e into cos 0. என்னது? parallel position. so which is minus p into e. so final potential energy minus initial potential energy தானா? so இங்க பாருங்க minus will become what? plus. so work to be done in rotating the dipole from the stable equilibrium வந்து we are rotating by how much angle? 90 degrees. அப்போ rotate பண்ணோம்னா what is the work to be done? p into e. what is the answer? இந்த மாதிரி question தான் வரும் maximum the questions based on the potential energy of the dipole, right? maximum this work done type of questions will come. so இப்போ பாருங்க like they have asked from parallel position வந்து rotating by 90. இதுக்கப்புறம் என்ன தெரியுமா, if we are getting some more question in the future examinations means they can give us questions like this. இப்போ theta is equal to 30 லேருந்து theta is equal to 60. அப்படி நம்ம rotate பண்ணோம்னா what is the work to be done? same concept. work to be done is equal to what? final stateல இருக்கிற potential energy minus initial stateல இருக்கிற potential energy, அவ்வளவுதான். because they usually don't mention about the kinetic energy concept. so அங்க இருக்கிற assumption என்ன தெரியுமா, the dipole is rotated very very slowly so that the dipole is not gaining any kinetic energy. அந்த kinetic energy தான் வராது. அதனால we will use work done is equal to what? வெறும் change in potential energy மட்டும். ஓகேவா? so like these kind of questions we need to be ready. the dipole based பண்ணா especially with regard to the work done, right? இதுல என்ன always the formula can be this one. work done is what? final potential energy minus initial potential energy, அவ்வளவுதான். ஓகேவா? so this is the kind of questions we can expect on the potential energy of the dipole in a uniform electric field. okay, next we look at this electrostatics of the conductors. Already nama appo we talked about this electrostatics or the behavior of the conductors in a electric field. And we even talked about the potential, electric potential on the surface of the conductor will be same as the potential at each and every point inside the conductor. And நம்ம ஒரு சில point space இருக்கும். இங்க என்னன்னா we'll try to summarize everything together. பாருங்க, first point என்ன, inside a conductor electrostatic field is zero. ஏன் தெரியுமா? If you are having a conductor வெச்சுக்கோங்க, if you are having a conductor, okay, the conductor will have theoretically infinite number of mobile charges. So if there is an electric field means enagum, like say for example the electric field is towards the right side vechukonga, then the charges will rearrange enna eppadi, because frankly speaking conductor kulla enna irukum, the mobile charges are actually what, electrons dana. Conductor kulla what is the mobile charges, electrons dana. So electrons will move in a direction opposite to the electric field. So appo enna theriyuma, indha pakka ella electrons vandu they will accumulate. So indha pakka enadhu electron deficit nu sonna positive charge. So adanal enagum, there will be an induced electric field which will be exactly opposite direction. Ipo nama apply panna electric field is towards the right side vechukonga, induced electric field will be towards the left side. And in the movement irukka, this is what we call as the rearrangement of the charge nu solluvom. This rearrangement of the charge will keep continue till the net field inside the conductor is zero. Net field enna theriyuma, the applied field minus induced field. Initially induced field value will be very small, but as the charges are getting arranged, right, in the back we are getting negative charge, right side we are getting positive charge. So as the charge accumulation is happening, the induced electric field value will keep increasing till it is able to exactly match the value of the applied electric field. So inside the conductor net electric field value will become what, zero. And in the process what is the time going to be taken? It will be in the range of milliseconds. It is not going to take like minutes or hours or kadayadu. It will take what, time which is in the range of milliseconds. The moment you place a conductor in an electric field, the redistribution happens and you will within less than millisecond you will find that and the conductor kulla what is the net electric field, zero. Okay, so adanala whether we have a conductor outside or even inside the electric field, the field inside the conductor will be what, inside the conductor field will be what, zero. Okay, wow, this is one of the point. Another point paranga, at the surface of a charged conductor the electrostatic field must be normal to the surface at every point. Okay, chinga paranga, ipo say for example this is the surface of the conductor edukonga. Okay, so enna sollirukom, the field should be normal to the surface. Okay, அப்படி இல்லைன்னா what is going to happen பாருங்க, இப்போ ஒரு contradicting நம்ம எக்ஸாம்பிள் கொடுக்கலாம். let's say for example ஒரு field is in some angular direction வெச்சுக்கோங்க, நார்மல் இல்லாம it is some angular direction. அப்ப என்ன தெரியுமா, we will get field ஓட perpendicular component வரும், அந்த மாதிரியே field ஓட parallel component வரும். அப்படிதானே, if the field is making an angle means அதுக்கு நம்ம ரெண்டு காம்பனன்ட் இருக்கலாம், ஒன்னு perpendicular component, ரெண்டாவது parallel component. இப்போ parallel component இருக்கிறதுனால what is going to happen, because பாருங்க கண்டக்டரோட சர்ஃபேஸ் மேலே சார்ஜ் இருக்கும். if there is a parallel component means the electrons on the surface will keep moving. திருப்பி இங்க என்ன ஆகும், rearrangement. எப்படி, they will rearrange in such a way that electrons, இப்போ electric field left side இருக்குன்னு வெச்சுக்கோங்க, electrons will move towards the right side. so அதனால right side will have electrons, இந்த பக்கம் என்னது will have the positive charge accumulation. so அதனால we will get induced electric field which will oppose it till the net is zero. so வெறும் இந்த perpendicular component மட்டும் it will be remaining. so whenever we have the conductor and the conductor surface kita, what is the direction of the electric field, it will be always normal to the surface. The surface curve, it will be what? Normal. So இப்படி இருக்க வச்சுக்கோங்க, like we have a irregular surface. இனி அப்படிதான், இந்த இடத்துல it will be normal, இந்த இடத்துல இப்படி it will be normal like this. இங்க எப்படி? Always நம்ம எங்க எடுக்க போறோமோ it will be always what? Normal to that particular surface. இப்போ இங்க surface ன்னு சொன்னா we have to draw tangential plane தானா, இங்க பாருங்க இது இப்படி. So always it will be what? Normal to the surface of the conductor. Okay, so inside the conductor field 0. Surface கிட்ட எப்படி? It will be normal to surface, parallel component இருக்காது. ஓகேவா? So normal சொன்னா don't always think that it will be always going away. It can be இப்படி இருக்கலாம், like you have a surface like this, it can be coming in also. It depends upon what? The charges on the surface of the conductor. The surface of the conductor மேல they say there is a positive charge வச்சுக்கோங்க, then field will be what? Radially outwards. அப்படி இல்லாம if the charge is negative, it will be what? Coming into the surface. ஓகேவா? அடுத்த பாயிண்ட் பாருங்க, electrostatic potential is constant throughout the volume of the conductor and the value will be what? Same as the potential on the surface of the conductor. The value will be same as potential on the surface of the conductor. இது ஆல்ரெடி நம்ம ரீசெண்டா பார்த்திருக்கோம் அந்த potential discussionல. So எதனால இப்படி, like if you have any conductor, right, let's say surface potential Vs னு வெச்சுக்கோங்க, surface ல இருந்து நம்ம உள்ள போனா electric field inside is what? 0. conductor குள்ள electric field is 0, right? So அதனால என்ன ஆகும்? When we are moving into the conductor, right, formula என்ன? If you are moving by a small displacement dr, the relation is what? Minus dv by dr is equal to E. அப்படிதானா? So E 0 means dv is 0 means what? Change in potential வராது, potential difference வராது, which means what? Surface ல இருந்து wherever you go inside, whatever point you take, potential everywhere will be same, which is equal to the potential on the surface of the conductor. Okay va? So potential everywhere inside will be what? Same, which will be equal to potential on the surface of the conductor. Okay va? So this is another interesting point. Another point பாருங்க, the interior of a conductor can have no excess charge in static situation. Okay, dynamic ன்னு சொன்னா தெரியுமா? If there is a charge redistribution happening, அதுக்கு நம்ம என்ன சொல்லுவோம்? dynamic ன்னு சொல்லுவோம். But static ன்னா when things are static, அப்போ we will not be able to have any excess charge in the interior of the conductor. பாருங்க, so conductor, any charge given to the conductor, charge will be only on the surface. Charge will be only on the surface. Charge will not be on the interior. So இப்போ இது ஒரு bulk conductor னு வெச்சுக்கோங்க. Bulk conductor means inside there is the material. உள்ள இருக்க like an iron piece or something like that. Okay, if you are giving a charge, நம்ம positive charge கொடுத்தா the entire charge will be on the surface. Every entire charge will be on the surface. Okay va? And if we are giving a negative charge means on the surface there will be negative charge. No excess charge can be there inside. எதனால தெரியுமா? If இது நம்ம அப்படி பண்ணலாம், like counter example. Say for example, அந்த conductor material குள்ள let us say there is a charge Q னு வெச்சுக்கோங்க. இருக்காது, but we are looking at what? Contradicting example. Let us say a charge Q resides inside the conductor. The conductor kulla, let's say there is charge Q residing. Inga enna theriyuma? If you try to take a small surface around it, enclosed surface. Enclosed surface edutha, what is this surface? Enclosed surface. Okay, so enclosed surface edutha, what is it that we have? Flux through the enclosed surface, Gauss law, right? What is it? Charge inside by epsilon naught. Flux through enclosed surface is what? Charge inside by epsilon naught. Gauss law. But இங்க என்ன பாருங்க, the enclosed surface is inside the conductor. Conductor குள்ள தான இருக்கா. Already we made one statement. What is it? Electric field everywhere inside the conductor என்ன 0. அந்த Gaussian surface மேல எல்லா இடத்துலயும் what will be the electric field? 0. If the electric field everywhere is 0 means flux through the enclosed surface will be what? 0 தானா? But the Gaussian surface மேல எல்லா இடத்துலயும் field is 0, which means flux will be 0. So if you are saying 0 is equal to q by epsilon naught, அதுக்கு ஒரே ஒரு possibility என்ன? q should be equal to 0 அவ்வளவுதான். அது தவிர there will be no other possibility. So இது எப்படி நம்ம இந்த ரிசல்ட் நம்ம கொண்டு வரது? First we are assuming that, let us say, நமக்கு தெரியாது அந்த conductor குள்ள whether there is a charge, excess charge can be there or it should not be there, அது நமக்கு தெரியாது. So அதனால நம்ம என்ன சொல்றோம்? Let us consider அந்த conductor குள்ள let us consider that there is a charge q. அப்புறம் we have taken an enclosed surface, Gaussian surface. So Gauss law என்ன வருது? Flux through the enclosed surface is equal to what? அந்த enclosed surface குள்ள இருக்கிற charge அது என்னது q divided by epsilon naught. But நமக்கு என்ன தெரியும்? This enclosed surface is inside the conductor and conductor குள்ள electric field is 0, which means அந்த enclosed surface க்கு மேல எல்லா இடத்துலயும் electric field is 0. அதனால flux should be 0. Flux 0 means அதுக்கு ஒரே ஒரு possibility, q must be 0. அதுதானா? So which means what? We initially began by saying let us consider there is a charge. Finally நம்ம என்ன சொல்றோம்? We'll say that this will be possible only when q is 0. Otherwise there is no possibility, which means what? The conductor, if you are giving a charge to the conductor, in that static situation la conductor kulla there cannot be excess charge. Enga irukum? Charge given to the conductor, right, will be only on the surface of the conductor. Surface mela da irukum. Okay va? So this is another important point about the electrostatics of the conductor. Another point paranga, the electric field at the surface of a charged conductor. At the surface and solradhukku we are going to take a point which is very near to the surface. We are going to take a point which is very near to the surface. இங்க என்ன தெரியுமா? So already இங்க ரிசல்ட் இருக்கா? இது எப்படி வருதுன்னு சொல்லிட்டு நம்ம பார்க்கணும். I think you remember we have discussed about this. Another, if you have a large infinite sheet made up of a conducting material, ஞாபகம் இருக்கா? Gauss law application. அங்க நம்ம என்ன பண்ணிருக்கோம்? We have taken a cylindrical type of a enclosed surface. One side is here, like surface area A. Okay. Ingon surface is inside the conductor. Ingane the electric field is 0. Here there is electric field. We have taken the surface charge density of that large infinite plate is what? Sigma. Adula namakku anga or result vandhathu enadhu? The electric field at this point will be what? Sigma by epsilon naught. Electric field because of a infinitely large conducting sheet. That is what we have seen from the Gauss law applications. Ingiyum we are going to take almost similar thing. Enna theriyuma? If we take a point very close to the surface of the conductor, we can assume that this is like what? Very large area. Appadi nam assume pannalam. Ena if you take, see, actual conductor idu chinnada irukala, but if the point is very very close, right, angala irundhu neenga paatha it will be like very large. So we take a point which is very close to the surface of the conductor. இது எப்படி? சேம் as it is தானா? ஸோ இங்கே நம்ம ஒரு சிலிண்டர் கிரியேட் பண்ண போகிறோம். திஸ் இஸ் தி ப்ரொஜெக்டிங் அவுட். இங்கே என்னது? திஸ் இஸ் த இன்சைட். ஓகே. ஸோ எலக்ட்ரிக் ஃபீல்ட் டைரக்ஷன் எப்படி இருக்கும்? இட் வில் பி நார்மல் தானா? ஸோ அதனால தி இப்படி தி சர்க்குலர் 1 and circular 2 flux through the circular phase 1 will be what? இப்போ இந்த சர்ஃபேஸ் நம்ம டெல்டா எஸ் நினைங்க, ஸ்மால் சர்ஃபேஸ். ஓகே. The area vector is in the same direction. So அதனால it will be what? It will be E into delta S. That is the flux through the circular surface 1. Circular surface 2 என்னது? 0. ஏன்னா அது எப்படி இருக்கா? உள்ள இருக்கா? கண்டக்டர் குள்ள எலக்ட்ரிக் ஃபீல்ட் 0 அங்க. The lateral surface இங்க பாருங்க, the field is like this, normal to the plate. Lateral surface area எப்படி இருக்கும்? So the angle between them எவ்வளவு? 90. Same as it is, நம்ம அங்க பார்த்த மாதிரி தான். The lateral surface flux value is 0. எதனால? Because the angle between the field and area element and சொல்லலாம் is 90. அதனால it will be 0. So வெறும் in the flux through that circular phase 1 மட்டும் it will be remaining. So what is that flux through the circular phase 1? This is what? Charge enclosed inside that Gaussian surface. நம்ம create பண்ண Gaussian surface. பாருங்க, what is the charge enclosed inside the Gaussian surface? The surface that is cut, the part of surface that is cut is what? Delta S dana. So the flux, which is what? E into delta S is equal to charge inside. Charge inside என்ன தெரியுமா? It is sigma into delta S divided by epsilon naught. Gauss law. Okay, so delta S cancel out. What is this E? Sigma by epsilon naught. Same result. Ramanda large conducting sheet as it is, same result. எப்படி இந்த result வருது? Because when we take the point very very close to that surface, the surface ரொம்ப கிட்ட நம்ம எடுத்தா it like what? The surface will look like very large surface, அவ்வளவுதான். Okay, so இங்க என்ன தெரியுமா? We have to understand one thing. Direction எப்படின்னு சொல்லிட்டு, it will be what? Perpendicular to the surface. Okay, so the n cap represents what? The unit vector perpendicular to the surface. N cap எப்படி? It will be unit vector perpendicular to surface. இங்க என்ன தெரியுமா? Sigma positive means it will be perpendicularly outwards. Sigma negative இருந்தா வெச்சுக்கோங்க, the charge on that surface is negative. அப்ப என்ன ஆகும்? E will be perpendicularly inwards. So இங்க minus வரும். So when you take the sigma value with sign, automatically it will adjust. N cap is what? Unit vector along the normal to surface. Okay va? Now depending upon the sigma, right? Sigma positive means electric field is what? Normal outwards madri. If the sigma is negative means what? Electric field is normally inwards madri varum. Okay va? So idu nama தனியா சால்வ் பண்ண ரிசல்ட் கிடையாது. ஆல்ரெடி இந்த ரிசல்ட் நம்ம பார்த்திருக்கோம் எங்க? The Gauss law derivations. But இங்க என்ன தெரியுமா? There is an important thing that we need to understand here. இது என்னன்னா, when you have a charged conductor, okay, if the charged conductor is having, say for example, the surface which is uneven, charge conductor matter, the surface is what? Uneven. So if the sigma values are changing, sigma values are changing, then wherever the sigma is higher, அந்த இடத்துல என்ன தெரியுமா? That electric field near the surface also will be higher. Wherever the sigma is higher, the electric field near the surface also will be what? Higher. Okay, so இது நம்ம ஞாபகம் வச்சுக்கணும். So if the surface is uneven, means and the surface of the curvature is keep on changing. Where the electric field is going to be higher, wherever the sigma value is higher, at that location electric field value will be what? Higher. So இதனால because electric field formula என்னது? Same the formula we have in the case of the infinitely large conducting sheet. Okay, அடுத்து பாருங்க, electrostatic shielding. இது ஒரு important useful property. என்ன தெரியுமா? Whenever we have these electric devices which may get damaged, and if lot of charge is getting into the devices, right? Sometimes that objects might get damaged, and even in some situations, like we'll see what are the practical applications on solute, we might be required to protect the devices from possible damage that can happen due to the very large electric fields. அதுக்கு என்ன தெரியுமா? we will use this concept of electrostatic shielding. First in the concept என்னன்னு சொல்லிட்டு பார்க்கலாம். If you have a conductor with an empty cavity, இது ரொம்ப important. Cavity and சொன்னா என்னது? Gap. இங்க பாருங்க, this is the conductor. இந்த blue நம்ம மார்க் பண்ணது இந்த conductor. அங்க என்ன like iron ஆகட்டும் or copper or whatever it is, அந்த மெட்டீரியல் இருக்கா. இது உள்ள என்னது? இந்த உள்ள நம்ம whiteல மார்க் பண்ணிருக்கோம். இது என்னது? This is the cavity. இது என்ன? Empty cavity. இந்த cavityக்குள்ள ஒண்ணும் கிடையாது. There is no charge inside the cavity. ஓகேவா? அப்படி இருந்தா then inside that cavity electric field will be zero. இந்த cavityக்குள்ள electric field will be what? Zero. அது மட்டும் கிடையாது. The potential everywhere will be same and it will be equal to what? Potential on this surface. இங்க பாருங்க, the surface. And this surface means because இங்கலந்து if you are moving into the conductor, right, electric field இருக்காது. Inside the conductor electric field is always zero, right? அதனால என்ன? The potential will be same throughout. இங்கே அப்படிதான். So potential inside the cavity will be same as potential inside the conductor. Okay. And the thing is, the cavity குள்ள the inner boundary இருக்கு தெரியுமா? The inner boundary of the cavity, அங்க charge accumulate ஆகாது. அங்க என்னது? Charge will not accumulate. ஏன்னா if the cavity is having accumulation of charge, the cavity is having accumulation of charge, right, then we can create a Gaussian surface inside. இங்க பாருங்க, we can create a Gaussian surface inside and that will disobey the conclusion. ஏன்னா because everywhere inside the conductor electric field should be zero, right? அது satisfy ஆகாது. Because if you are saying that there is a charge on the cavity surface, right, it will disobey the Gauss law. அதனால the cavity surface இருக்கு தெரியுமா, அதுக்கு மேல charge வராது. So பாருங்க, what are the things? If you have a open cavity or empty cavity இருந்தா inside a conductor, right, அந்த cavity குள்ள electric field everywhere is zero. அது ஒண்ணும். ரெண்டாவது என்ன? அந்த surface மேல, cavity ஓட surface மேல charge accumulate ஆகாது. And potential everywhere will be same. And the value will be equal to what? Potential inside the conductor. Okay. இப்போ நம்ம இந்த கண்டக்டருக்கு மேல we are giving a charge means அது எங்க reside ஆகும்? Outer surface மேல தான் இருக்கும். If you are giving a charge to the conductor means it will be only residing on the outer surface. எங்க பாருங்க, இப்படி it can be somewhere. Negative charge கொடுத்த ஒரு இடத்துல இருக்கலாம், positive charge can be somewhere, but the charge given to the conductor will be only on the outer surface மேல தான் இருக்கும், உள்ள போகாது. It will not even accumulate on the cavity ஓட boundary மேல accumulate ஆகாது. Okay. So this property, right, is used to prevent some electrical devices from getting damaged. ஏன்னா if you are having, say for example, ஒரு sensitive device இருக்கு நம்ம கிட்டன்னு வெச்சுக்கோங்க, அதை அப்படியே எடுத்துட்டு நம்ம உள்ள போட்டா then whatever might happen outside you may create large electric field, but அதோட impact will not be felt by the device. Now the cavity குள்ள போட்ட device will not get damaged. Okay. So இது எப்படி தெரியுமா? இதோட practical applications, like if you are looking at the lightning, நீங்க rainல if you are going outside means you would see that your parents will keep telling you, don't stand below the trees அப்படினு சொல்லிட்டு, don't stand in places which are open, because there is always the possibility of the lightning to strike you. ஏன் தெரியுமா? Because always the lightning would want to take. So this is another concept of physics. So from the clouds, when the charge is lightning, also what is it? It's a charge that is getting transferred from the clouds to the surface of the earth. Okay, va? So in the between, what is there? There is air, which is a, we'll call it as a dielectric substance, poor conductor. Other the charge that is coming down, right, will always want to take a shorter path through air, and it wants to always get into a path where it will be able to have better conductivity. Okay. So if you are having a very large tower in Vechkonga, if you are having a very large tower, then instead of coming through the path, right, the lightning will actually go, charge will go into the tower and then it will go. So apadi work agum. So it will always try to take a least resistant path. Like we'll go to the current electricity, angu nama idu pathi pesa porom. Whenever we are having a flow of charge, then the current dana, current will always want to take a least resistance path. So it will not be coming down from a cloud, it will not come down to surface. It will always take to a medium where it will be able to conduct fast. Okay, so if you are standing upright, right, if there is a path which can give the lightning better conducting medium, it will always take that particular path. Okay va? So if you happen to be there, means you will get hit. You and sonna, like, whoever is there, right, there is a chance that they will get hit. But eppadi nama avoid pandrathu? If you are imagine sitting inside a car which is made up of a conducting material, paranga idan theriyuma, it is like you are inside the cavity, appadidana. So car surface enna, it's like a conducting material. Then a car is made up of typically metal, conducting material. So the charge is coming and falling on the surface, but enna agum appadiye and the charge surface mela da accumulate agum thavara it will not be coming into the cavity, and automatically it will be discharging to the ground. So nothing will happen to you who is sitting inside the cavity. So that is the reason why people say that you go into a shelter. So whenever rain is happening, you go into shelter here, because there is a chance that we will get protected because of that electrostatic shielding. Like typically you look at anything, right, like a car or something, you can see it like what it can be seen like a cavity. So the cavity kulla poi neenga ukarnu vechukonga, then what happens, you will be protected. Outside, whatever charge may be coming out of the car, large amount of charge might come and fall, but the charge will automatically be moving only on the surface mela move agum, and it will be passing to the earth. Nothing is going to happen to you. Okay va? So this is about the practical application of the electrostatic shielding. Okay va? So electrostatic shielding la main concept enadi, if you are having empty cavity, இது ரொம்ப important. Cavity குள்ள நம்ம charge இன்னும் place பண்ணக்கூடாது. It should be empty cavity. Empty cavity இருந்தா, then inside the cavity the field will be zero. Potential inside the cavity will be everywhere same, which will be equal to potential in the conductor. அந்த மாதிரி இந்த cavity surface இருக்கு தெரியுமா, அந்த surfaceக்கு மேல charge இருக்காது. Cavityயோட surfaceக்கு மேல charge இருக்காது. Okay, ஏன்னா if there is a charge accumulation means என்ன ஆகும், it will disobey the Gauss law. நீங்க ஒரு Gaussian surface எடுத்தா it will disobey the Gauss law. Okay va? So this is about the electrostatic shielding and other practical applications. So this is about the concept of the conductors in electrostatics. Next class we'll start with the discussion about the dielectric substances. Adukapram we'll go to the capacitors. Okay, so capacitors we'll be completing it. Capacitors is important because if you see, like at least half the number of years they are asking questions on the potential and energy, means other half they will be asking on the capacitors, which is a very small concept but important. Adha nama paaka porom. Okay va? We'll see in the next class.